Good morning, good afternoon, or good night. This is Scibricks, and today's topic is on one-directional motion, which is just distance and displacement, a topic covering physics but simplified. So, what is distance? Distance is a measure of how much ground an object has covered, regardless of whether it started in a straight line, it took a zigzag path, or came back to its starting position. It's a scalar quantity, meaning it only considers magnitude and does not consider direction. Magnitude is numbers, and direction could be north, south, east, or west. To simplify this, we can just say that distance is the total length of your journey and is a scalar quantity, so you only need to know the numbers. Distance is also measured in any unit of length, which can be kilometers, meters, miles, etc. For example, if you traveled 5 miles from your school to your house, the distance traveled will be 5 miles. And now we move on to displacement. So basically, displacement is a measure of change in position of an object. So it can change from north to south, from east to west. It basically includes how far an object has moved and the direction of its movement, to its initial point to its final point. Displacement, unlike distance, is a vector quantity, which means it has both magnitude, numbers, and direction, north, south, east, or west. To simplify this, we can just say that displacement is how far away you are from your starting point, and is a vector quantity, meaning it has both direction and magnitude. For example, if you walked 5 miles east from your starting position, your displacement will be 5 miles east. Now, to summarize all of this up, distance is a scalar quantity, meaning it only has numbers and has no sense of direction, unlike displacement, which is a vector quantity and has numbers and direction. Phew, that was a lot to take in. I get it. But hey, hopefully you understood the basics to distance and displacement. If not, don't worry. We still have one more problem you can solve. You ready? It won't be hard. I promise. Sarah goes for a walk from her house to the park and back. She walks 2 miles to reach the park and then walks 2 miles back to reach her home. What is her distance and displacement? Her distance is 4 miles, and her displacement is 0 miles, as her starting point is home. So when she travels back home, she is 0 miles away from home. Distance and displacement are concepts that are used in various fields around the world. So I'm just going to mention a couple, such as navigation. This concept is crucial for navigation in air, sea, or land. It also aids navigational systems. Astronomy. Astronomers use this concept to measure vast distances between planets, stars, or other celestial objects in the universe. Sports science. Coaches and athletes use this concept to analyze a sports performance, such as measuring how far an athlete runs, jumps, or to help analyze players' movements and strategies. Economics. Economists use this concept when studying trade and transportation. They consider how distance affects the cost of transporting goods. Lastly, we have engineering. Civil engineers use this concept to plan out and create bridges, along with roadways, while mechanical engineers use this concept to design and analyze motion for the function of mechanical innovations. Whoa! Would you look at that? There's the Burj Khalifa!